10.3 talks about matrices and systems of linear equations. A matrix is defined as a rectangular array of numbers. Pretty much it's a list of numbers. It's really a list of vectors, if I want to be specific. And each matrix, the notation for a matrix, the notation for the determinant. So those are different notations. Every matrix consists of dimensions. This is column 1, this is column 2, all the way to column M, column N. This is row 1, this is row 2, and this is row M. So you always write the number of rows and the number of columns. This is the dimension of the matrix, and that's a must. You need that for few of the applications of matrices. So a matrix is always written this way, and you write the number of rows, the number of columns after. So given a system of equations, ax plus by equals c, dx plus ey equal f. An augmented matrix is a matrix in which, now the books, some books write it like this, and some books write it like this. I like this notation better. I'm going to be using that, even though our book might use it on and off, but there it is. So I could take a system, and you notice the coefficients are right there, and the constants are right there. So a couple of things we need to really figure out. The goal in this first video just to get you acquainted with this. We're not going to fully finish this until the next video. So if I look at the first problem, it says state the dimension of each matrix. So you look at a matrix, you say, okay, how many rows are there? Row 1, row 2, that's a 2 by, and that's a column 1, column 2, third column. That's a 2 by 3 matrix. It's very important to get those right. This matrix right here is 1, 2, 3, and there's only one column. That's a 3 by 1. This matrix right here is 1 row, 2 row, 3 rows, 1 column, 2 columns, 3 by 2. And that's all you have to do on those. Now, on the next set of problems, I would like to go from the system of equation to an augmented matrix. So, if I look at the first, if I want to write this in augmented matrix, I'll copy. You make sure that the column refer to the same variable. The variable has to be the same. If they're not in order, you line up the x's. That's 1, 2 for the x's. The second matches the same variables. That would be a -3 and a 1. And the constants go at the end. And if I am to create an augmented matrix for B, all the x's are lined up. It's 1, 2, 1. The y's are lined up, -3, 1, 2. And if they're not lined up, you need to line those up. And the z is 1, -2, and a 4. And the coefficients, or the constants, here they are. So this is the augmented matrix for part B. And this is the augmented matrix for part A. Alright, next up, perform the indicated operations. I want row 2, remember this is representing row 1 and this is representing row 2. I want row 2 to become -2 times row 1. Well, let's see how that works. If I am to take -2 times row 1, there's row 1. If I multiply this by -2, that would be -2x plus 6y equal a -6. Add that to row 2. Row 2 is 2x plus y equal a 5. And if I add those, I'll get a 0. I'll get 7y, and I'll get a negative 1. So now my system looks like, so notice row 2 changed. Row 1, I'm not touching. Row 2 would be a 0 minus plus 7y equal negative 1. That's pretty much what that means. Now, we're going to take this idea that I just did, and we're going to apply it one more time. Except now what we're going to do, we're going to write this in augmented matrix form. So I'm going to take this A, let me just, so this we did using what we already know. Now I'm going to take A and write it in augmented matrix form. 1, negative 3, and a 3. 2, 1, and a 5. And I'm going to apply this on it. What does that mean? Row 2 is, so this is row 2. That's going to become negative 2 times row 1. Multiply row 1 by negative 2. That's a negative 2, a 6, and a negative 6. Add it to row 2. Row 2 is 2, 1, 5. If I add those, that's a 0, that's a 7, and that's a negative 1. And my new augmented matrix would be, so row 2 is changing. It's right there. It's 0, 7, negative 1. And row 1, I didn't change. I just used. So, we're going to get out of this system of equations, and we're going to use augmented matrix form. Notice here, whether you put the 0 there or not, it's up to you. But here, it's a must. Sort of when you wrote problems in syntactic division, you had to really fill in the zeros. You couldn't take the zeros out. Here, I'm going to do the same. The goal normally, when you start doing those, is to make that a 0. If I was to say, how do you get rid of x? Wouldn't you say multiply the top equation by a negative 2? That's pretty much what this is doing. Here, if I want to make that a 0, how do you do that? Well, multiply this row by a negative 2 and add it to row 2. But put the result in row 2. And if you want to make this a 0, what do? Multiply row 1 by a negative 1 and add it to row 3. Well, for now, you just have to follow, but they don't like the x's and the y's. They like us to use augmented matrix form. Augmented matrix form looks like this. So we have quite a bit of terms to worry about, and let's get that out of the way. Meaning, let's take negative 2 row 1. So negative 2 row 1 is negative 2, a 6, a negative 2, and a negative 6. Add it to row 2. Row 2 is 2, 1, negative 2, and a 5. If I add those, I'm looking at 0, 5, negative 4, and negative 1. Where do you put that? You put that in row 2. So in my new augmented matrix, on my next step, I noticed that row 2 and row 3 are changing. Row 1 is not. I copy row 1 because that's not going to change. I could use it, but I'm not changing that. Row 2 now just became 0, 5, negative 4, and negative 1. Now, I want to do this part. I want to take row 3. That's this row 3. The new row 3 is going to be negative row 1. If I take row 1 and multiply it by a negative, isn't that negative 1, a 3, a negative 1, and a negative 3? Add it to row 3. Add those two. Negative 1 plus 1 is a 0. I want that in row 3. 3 plus 2 is a 5. Negative 1 plus 4 is a 3. And negative 3 minus 2 is a negative 5. And that's all you have to do. So either they write it like this, or they tell you literally what to do. Multiply row 1 by negative 2, add it to row 2. And one more thing I need to get out of the way before I conclude this first video, which is the introduction of how to transform. Something called backward substitution, or back substitution. So if I look at this, they tell me these are augmented matrix. Again, I really prefer seeing the line there. This book stopped doing that, which is kind of annoying. they used to before. Alright, if this is an augmented matrix form, it says, given the augmented matrix, write the system of equations and use backward substitution. Well, let's see. If the first is x, the second is y. If I use backward substitution, the benefit of this being a 0, this says 2y equal 4. That's what backward substitution means. That means y equal a 2. And now what? Now you go back one step and you say, well, x plus 3y, but y is 2, equal a 5. X plus 6 equal a 5. So now I could figure out what x equals. X equals a negative 1. And by doing so, I'm able to say the solution to this system is negative 1, 2. If I look at this problem, backward substitution, the first is x, the second y. This third line says 0x plus 0y. It says z equal negative 1. Got one variable. Backward, that means go back one step. That middle second row says x, y, I'm sorry, not x, y plus 2z. Well, z is negative 1 equal a 6. That means y equal an 8. Very good. Go back one level. So now if I take x plus 2y, but y is 8, plus 5 times z, but z is negative 1 equal a 2. X plus 16 minus 5 equal a 2. X plus 11 equal a 2. X equal negative 9. So my solution to this problem is negative 9 for x, 8 for y, and negative 1 for z. What does that mean? You replace x by a negative 9, y by 8, and z by a negative 1. In the first equation you get a 2, in the second equation you get a 6, and in the third equation you get a negative 1. That's what that means. A solution to a system of equations would be the value of the variables that equate every equation in the system. Now, what if I wanted to do that on this? Well, the same deal. I notice the third has the most zeros. That's the benefit of this. And the next step is for us to take an augmented matrix and make it look like that. If I take the third equation, that says z equal 4. Done deal. I got one variable. Go back one level. That's back substitution. Above, it says y plus 3z equal 9. But I know what z is. Z is a 4. So this is 12, y equal a negative 3. And now if I go up one more, x minus 3y plus, there's no z, right? You don't have to put that 0. I'm just putting that for your notes. X minus 3 times negative 3 equal a 9, equal a 7. You know what I'm thinking, right? X plus 9 equal a 7. Subtract 9 from both sides. There it is. So, x is negative 2, y is negative 3, and z is a 4. The last two examples before we conclude this first video deals with the special cases. If you remember, we could have a no solution or an infinite amount of solutions. So, if I look at this, and again this is an augmented matrix, I notice here if I want to start backward substitution, this says 0 times z equal negative 1, but 0 times any quantity is 0, and there's no way 0 could be a negative 1. So this has no solution. Alright? So write it out if you're not sure. And here it says 0 times z equals 0, 0 equals 0. That's an infinite amount of solutions, but not any solutions. You can't say all real numbers. Reason for that, if I pick the point 0, 0, 0, that wouldn't work. Right? I think I messed it up. I'm trying to get more space. There we go. Now it's better. Okay. So, if you say all real numbers, or any number will work, well, I'll say, okay, 0, 0, 0. Put 0 for x, 0 for y, that doesn't equal 7. So what do you have to do? You have to use backward substitution, but this is a 0. What does that mean? That means you do exactly what we did on the previous two problems. Here we got z to be negative 1. Here we got z to be 4. Here you say, you know what? Let's say z is t. So let z equal t, where t is any number. Backward substitution. Doesn't this say y plus 3z equal a 9? Y plus, but we already agreed z is going to be t. So doesn't y equal 9 minus 3t? Very good. Well, go back one up. X minus 3y plus 0z equals 7. X minus 3. We know y is 9 minus 3t. If there was a z, I would have put that in there, but there isn't. X minus 27 plus 9t equal a 7. Remember, I want x. So x would be 34 minus 9t. And you write the solution as x is 34 minus 9t, y 9 minus 3t, and z is t. And what's t? T could be any number that you want. What that means, give me a value of t. If you give me 0 for t, 0, 9, 34 would be a solution for each of those. And you could check. You could put 34 right there. Minus 3 times 9 is 27. 34 minus 27 is 7. And if you put a 9 there, 9 times 1 plus 3 times 0 is 9. That works. So the solution must satisfy this case. You want another solution? Not a problem. Pick another value for t. Let's say t equal 1. 9 minus 3 is 6, and 34 minus 9, 25. So you have an infinite amount of solutions, but they must satisfy this relation. And that's where we're going to stop for this video.